Hello friends, welcome back. In previous few videos, we have seen the various terms used in the coordination chemistry. Now in this video, we are going to study the oxidation number or the oxidation state. So let's start with this. So first of all, we have to study the term charge on the complex ion. Okay, so what is a complex ion? The complex ion means it is a formula which is written in a square bracket, and it may be on the square bracket, it may have some charge which may be positive or the negative. So we can say that the charge on the complex ion is the algebraic sum of the charges carried by the central metal ion and the ligands attached to it. Okay. So the charge on the complex ion, it depends upon the nature as well as the number of the ligands, or we can say the coordinating groups which are attached to the central metal atom or the ion. The charge on the complex ion may be the positive or the negative. So let's see an examples. So this is the first example, CONH3 5Cl. Okay, so this is a complex ion. The formula is in the square bracket. So it is a complex ion. On this square bracket, we are having a particular charge. This charge is +2. So we can say that this +2 is the charge of this complex ion. Similarly, the second example, FeCl6 3-. Now here again we can say that this 3- is the charge on this complex ion. Third example, PtNH3 2+. Again this 2+ is the charge on the complex ion. So let us see one more structure. So this is the structure of CONH3 6. Now again this complex ion, it is having one charge, and that charge is the +3 charge. So this +3 charge is the charge on this complex ion. So in this we can say that the charge on the complex ion is the sum of the charges carried by the central metal ion as well as the ligands attached to it. Okay, so after this term, let's move on. We have to study the oxidation number or the oxidation state. So what is the oxidation number or the oxidation state? So we can say that the charge on the central metal atom or the ion in a coordination compound is known as the oxidation number or the oxidation state. Or we can simply say that the numerical charge along with the sign which the element appears to have in combination with the adjacent one is also known as the oxidation number. The oxidation number or the oxidation state is the characteristic of the central metal atom or the ion. Further, we can say that the oxidation number is the actual charge associated, or we can say it is present on the central metal atom or the ion. Further, we can say that the oxidation number may be 0, it may be positive, it may be negative, it may be integer, or it may be a fraction. Okay, the positive oxidation number indicates that the number of electrons which must be added to cation to give a neutral molecule. Okay, that means to form a neutral molecule, we have to add some electrons to the cation. That indicate the positive oxidation number. Similarly, the negative oxidation number means it indicates the number of electrons which must be removed from an atom to give a neutral molecule. So this oxidation number, it is shown by the Roman numbers such as 1, 2, 3 or 0. Now let us see the rules to assign the oxidation number. So various rules to assign the oxidation numbers are: the first rule is the oxidation number of a free uncombined element is always 0. So the element which is always free or it is uncombined, the oxidation number is the 0. For example, sodium, potassium, calcium, etc. All the three, they are free, or we can say that they are uncombined. That's why the oxidation number is the 0. Also, the atoms in the molecules like the oxygen, nitrogen, hydrogen, chlorine and the phosphorus, all they are the free. Therefore, the oxidation number is always 0. Okay. Then the second rule. the oxidation number of metals is always positive. The oxidation number of metals is always positive in its all compounds. So we can say that the oxidation number of hydrogen is always +1 except in metal. Except in metal hydrides where it is -1. That means the oxidation number of hydrogen is always taken as a +1. But when it is present in metal hydrides, it is treated as -1. Okay. For example, oxidation number of hydrogen is NH3, H2O, HCl. In all these three, the oxidation number of the hydrogen is +1. Right? But the oxidation number of hydrogen in metal hydrides. Metal hydrides means when the hydrogen is attached to a metal such as CH2, lithium hydride, sodium hydride, etc. Now here in these cases the oxidation number of hydrogen is always -1. So this is the second rule. Then the third rule, the oxidation number of oxygen is always a -2 except in fluorides and the peroxides. That means for the oxygen fluoride, that is OF2, the oxidation number is +2. The oxidation number of oxygen is +2. Similarly for the peroxide, that is hydrogen peroxide or the sodium peroxide, H2O2 or the Na2O2, the oxidation number of oxygen is -1. Okay, so this is the third rule. Fourth rule, the oxidation number of alkali metals is always +1 in their compounds. For example, potassium in KCl and sodium in NaF, it is always +1. Fifth rule, the oxidation number of alkaline earth metals is always +2 in their compounds. For example, calcium in calcium oxide and magnesium in magnesium oxide is always +2. Then rule number 6, the oxidation number of halogen is -1. For example, chlorine in NaCl and iodine in Ki is always -1. That means the oxidation number of halogen is always -1. Then rule number 7, the oxidation number of sulfur in metallic sulfide is -2. For example, sulfur in ZnS and the Na2S is always a -2. Then rule number 8, in neutral compounds, the sum of oxidation number of all the atoms taken together is always 0. And the last rule, that is the rule number 9, in polyatomic ions having positive or the negative charges, the sum of oxidation number of all the atoms is equals to the net charge on the ions. So these are the rules. By following these rules, let us move to the next point, that is a calculation of oxidation state of the central metal ion in the coordination compounds. Okay, so we have to find out the oxidation state of the central metal ion. So we have to solve some examples. So first example is FeCN6 3-. So here we have to find out the oxidation state of the central metal ion. So which is the central metal atom or the ion? Fe. Ion is the central metal ion, and here we have to find out the oxidation number of the Fe. So let's start with this. So let the oxidation number of Fe be X. So let us consider the oxidation number of Fe as a X that we have to find out. Then total number of ligands. Which are the ligands? Cyanide. How many total number of ligands are there? 6. So it is equals to 6. Then charge on the ligands. So for the cyanides, we are having the -1 charge. And how many cyanides are there? 6. So we can write total charge on the 6 cyanides. It is equals to 6 into -1, which is equals to -6. And then the charge on the complex. Charge on the complex is -3. Okay. Therefore, we have then the summation of all these. So it becomes X. For the Fe, it is X plus -6 for the 6 cyanides, which is equals to -3, which is the charge on the complex ion. So X plus -6 is equals to -3. Therefore, X is equals to +3. Hence, we can say that the oxidation number of Fe is +3. Hence, Fe oxidation number of Fe in FeCN6 3- is +3. that is a Roman plus 3. So this is the first example. Then the second example. Second example is FeCN6 4 minus. Now here again the central metal at ion is the Fe, and for which we have to find out the oxidation number or the state. So the first point will be, let the oxidation number of Fe be X. Then total number of ligands, that is the cyanide ligands, are 6. Charge on the ligand is equals to -1. Therefore, total charge on the 6 cyanides, that is 6 into -1, which is equals to -6. Then the charge on the complex, which is equals to -4. Therefore, we have X plus -6, which is equals to -4. Therefore, X is equals to +2. And hence we can say the oxidation number of Fe in FeCN6 4 minus is +2, that is Fe plus 2. Okay, so this is the second example. Third example is MnCl4 2 minus. Which is the central metal atom? The central metal atom is the manganese, Mn. Mn is the central metal atom or the ion for which we have to find out the oxidation number or the state. So let the oxidation number of Mn be X. Total number of ligands, that is the chlorine ligands, which are 4 in number. Okay, the charge on the ligand is -1. Therefore, total charge on 4 chlorine, that is 4 into -1, which is equals to -4. And hence the charge on the complex, which is equals to -2. Therefore, we have X plus -4, which is equals to -2. Therefore, X is equals to +2. And hence oxidation number of Mn, that is a manganese in MnCl4 2 minus is +2, that is Mn plus 2. Let us move to the next example. Next example is COF6 3 minus. Now here CO is the central metal ion and the fluorine is the ligand. There are 6 fluorines. So let the oxidation number of cobalt be X. Then total number of ligands, which are the fluorine, which is equals to 6. The charge on the ligand is equals to -1. Therefore, the total charge of 6 fluorine, that is 6 into -1, which is equals to -6. Then the charge on the complex is equals to -3. Therefore, we have the summation of all these, that is X plus -6 is equals to -3. Therefore, X is equals to +3. And hence we can say the oxidation number of cobalt in COF6 3 minus is +3. That is cobalt +3. Right. Next example. Next example is nickel tetracarbonyl, that is NiCO4. Now it is a neutral complex. That means there is no charge on the complex. The central metal ion or the atom is the nickel and the ligands are 4 carbonyls. And for the nickel, we have to find out the oxidation state or the oxidation number. So the first point will be, let the oxidation number of nickel be X. Then the total number of ligands, the carbonyl ligands, they are 4 in number. Then the charge on the ligand, the carbonyl, they are neutral ligands. Therefore, the charge is 0. Therefore, we can say the total charge of 4 carbonyl, that is 4 into 0, which is equals to 0. Then the charge on the complex, which is equals to 0. Therefore, we may write the summation of all these, that is X plus 0, which is equals to 0. And hence, X is equals to 0. So, we can say that the oxidation number of a nickel, that is Ni in NiCO4 is 0. That is Ni 0. Right. Let's move to the next example, that is CONH34H2OCl. Now here there are 3 different types of ligands. The first ligand is the NH3 ligand, second is the H2O ligand, and third is the Cl ligand. Now this NH3 and the H2O, they are the neutral ligand. That means they are having the 0 charge, whereas the chlorine is having the -1 charge. So let's put the charges. So first of all, for the cobalt, we have to put the X. For the cobalt, we are having the X. That means we have to find out the oxidation state or the oxidation number for the cobalt, which is a central metal ion. Then for the NH3, it is a neutral ligand. There are 4, therefore 4 into 0. H2O, H2O is also a neutral ligand. And for the Cl, we are having the -1. And the total charge is the +2. So let's put this. So for the cobalt, we have to put X. For the NH3, we have to put 4 into 0 as there are 4 NH3 ligands. Then for water, it is 1 into 0. For Cl, it is -1 and which is equals to the charge that is +2. Right? If we carry out the summation of all this, we write X minus 1 is equals to +2. Therefore, X is equals to +3. So we can say that the oxidation number of this cobalt in this complex ion is the +3. That is cobalt +3. So these are the various examples in which we are getting how to find out the oxidation number or the oxidation state of the central metal atom or the ion. Thank you.